Hi scholars, welcome to the second section of chapter 1.3. So again, just to reiterate for your warm-up, you guys should have already done the topics for the part 1 of section 1.3. That way when you arrive to any warm-up problems, like for example, these next 3 problems, you should be already ready. These 3 problems should be pretty easy for you because you've already done the homework for them. So if they are complicated for you, please don't even start this lesson. Go back to your old notes, review them, do some topics, then come back. Okay, so pause here, do your 3 warm-up problems, and then return back for your answer. All right, so for number 1, you're just evaluating expressions, kind of like course readiness stuff. You're just plugging in numbers for variables and evaluating. So I wanted to show you here, people get so into the habit that when I was teaching clearing fractions, you guys want to clear all fractions for like the rest of your life now. Remember, you can only clear fractions if there's an equal sign and you're solving for a variable, for example. So this is just a straight up adding, subtracting fractions problem. So you're just making common denominators like you would in Algebra 1. Which is different from number 2, this is where you clear fractions. Notice the difference between number 1 and 2 and when to clear fractions and when to not to clear fractions. Number 2 has an equal sign and you're solving for the variable x. So that should tell me that I'm clearing fractions to get rid of them. Okay, so I multiplied everything by the LCD, which was 6 in this case. And again, remember, as soon as you arrive to your second step, which is this step, you should have no more fractions. Get rid of them. If there's still fractions in that second step, you did something wrong or you're taking too long to do the problem. And then the last one was introducing the fact that we have multiple solutions to solving equations now. So we have an option of no solution, infinite solutions, and just our standard 1 solution. So this was a 3 equals 0, which is a false statement at the end. Remember, that's not your answer. The answer is no solution. All right, so the second part, of chapter 1.3 is we're going to continue on with clearing fractions. We're just going to get a little bit of harder problems. So please practice these. I'm only going to do 2 of these because it's the same concepts that we've been doing, but I really want you guys to be concentrating on them with your topics. So I'm not going to go over them too much because the concepts are the same. You guys really just need more practice. And the rest of the time today we'll be dealing with word problems. And they're not too hard. So we're kind of just touching on like the lighter ones. So again, we're clearing fractions, exact same idea as before. We just have now expressions on the top instead of just numbers. Okay, so you just have to kind of learn to distribute and get very careful. All right, so again, we want to look at your LCD. Technically, 7 is over 1, so if you need to put that to remind yourself that 7 is not a denominator, go for it. So you have 4, 5, and 1 as your denominators. What is going to be your LCD? So it's going to be 20, so I'm going to put 20 over 1 next to or in front of each of my terms. All right, so let's get started. So 4 goes into 20 5 times, and now we have something more on top than we've dealt with yet. So you're actually going to have to distribute this. So there's 2 ways you can do it. I probably in this first problem, I'll go slowly for you guys, for those of you who want to take your time. So I'll just write the numerator out. So it'll be 5 times 9x minus 1. Then we'll do the same thing for 5 goes into 20 4 times. And here's where a lot of mistakes are going to happen right here. So this negative sign, a lot of people just put it with the 7x and then they continue moving on. Again, this is an expression. You should put parentheses around your numerator as an expression so you do not make this careless error. Okay, this negative should be applied to the 7x and the 2. That's where so many little errors happen, especially on your test. We're going to for sure put some type of question like this just to see who's paying attention, who's not. Okay, so you can do a couple different things here. Or you can do this. So you could either apply the negative 7 into the 2 right there, or I can just change this 4 to the negative. And I'll probably do that just to keep it a little bit easier. Okay, so I'll do negative 4, 7x plus 2. equals, and then you just do 7 times 20 because there's nothing to cross out there. So this would be 140. So again, this section right here was your hardest part. There's like negatives there, so just be very, very careful. Okay, so now we're just going to distribute and solve. So again, at this step, no fractions are allowed. If you have fractions, you need to back up because you did the problem wrong. So 45x minus 5 minus 28x minus 8. We combine like terms on the left-hand side. And now we just start isolating your x, and you should get x equals 9. Again, if this was a quiz or a test and you were like nervous about that whole negative thing on top, you can always plug in your answer 9 into your equation. If it comes out to be a true statement, then you know you got the answer right. So there's always a way to check your answer. So I would suggest doing that if you're nervous about any careless errors on here. All right, let's try number 2. Okay, again, 9 is not a denominator, so don't count it in your LCD. It's 9 over 1. So 4, 1, and 5, again, are your numbers to deal with your LCD. So that means 20, again, is your LCD. All right, let's get started. So 4 goes into 20 5 times. So you can do it this way. You know, in this other problem, I just wrote it out in this step. If you'd like to go a little bit quicker, you can already distribute in this step. That's if you can keep your work nice and organized. If you're not one of those students, then please do what I did in the previous problem. All right, in our second term, there's nothing to cross out, so you just do 20 times 9, which is 180. And now this, again, we have to be very careful. You look at this minus sign, you know something can carelessly happen. So either change this to, or distribute this like this, and then change this to a plus sign, so you don't make mistakes, or again, just do this, where we do 5 goes into 20 4 times, and then I'll just bring this 4 over to make it -4, and now I distribute -4 into each of these parentheses. So whichever way best suits you, but please take into account that negative sign into that entire expression. So people always forget about this guy in the back, and that's where they get problems wrong. All right, so now we have our equation. We're just going to solve now, and the rest of this problem should be pretty easy. So we're going to combine each side. So 33y equals 198. And then you should get y equals 6 as your final answer. And again, if it's a high stakes test, I would totally plug this into y, just checking to make sure my answer is correct. So again, I just briefly went over 2 questions. You definitely need a lot more work with this concept, but I can't keep on just practicing clearing fractions when we've done it in the last section. So please try that on your own, and please come to me with any questions. All right, so like I said, for the rest of the time, we're gonna be doing word problems. So I'll show you guys these. And for today, we're only dealing with one variable word problem. So I'm not gonna have you say, let x equal something, let y equal something. We're gonna come to that at a different point, but we're just gonna use one variable. So number 1 says, TechWiz Electronics makes a profit of $35 for each MP3 player sold and $18 for each DVD player sold. Okay, so I just like to highlight important information. So 35 for each MP3, 18 for each DVD. So those are the 2 things we're talking about. Last week, TechWiz sold a combined total of 141 MP3 and DVDs. So adding those 2 together, we get 141. Write an expression. Remember our differences between expression and equation. Expression does not have an equal sign. We're not solving for anything. We're not going to say x equals some number. So just an expression for the combined total profit the two companies made last week. All right, so let's get started. So I'm going to say let X equal MP3 players sold. So how many MP3 players were sold is going to be X. They sold 141 in total MP3 and DVDs. Okay, so let's, again, I like to think of examples because sometimes you guys don't know how to think in general terms of like X, like some random number X. So I just like to substitute answers. So let's pretend there was 100 MP3 players sold last week. If we have 141 total, then how many DVD players did we sell? Well, you would just subtract, right? 141 from 100. So you would get 41 DVD players sold. Again, I'm just making up numbers to try to get the second expression. So what we did there was subtract 141 from our X. So that's how you arrive to how many DVD players were sold. Okay, so you take the total minus the MP3 to get your DVD sold expression. Okay, so now that we have something written for your MP3s, you have something written for your DVDs, we now use that first sentence again to try to get the profit in dollars. So if you look at that pink highlight, it says they charged $35 for each MP3 player. So 35X, because X is representing MP3. Okay, the second highlight was that $18 are being spent on each DVD player. So 18, and then DVD player is that expression. So times the quantity, 141 minus X. Okay, and now all you have to do is combine like terms and distribute. So 35X plus 2538 minus 18X. And then just combine, so you get 17X plus 2538. And again, that's your expression for the combined total profit. All right, number 2, same idea. So you're always on the left-hand side. I like to just designate these like little expressions like so, and then you use your information to write out a expression to simplify. So let's do the same thing with number 2. Yesterday, John went on a bike ride. His average speed was 9 miles per hour. That was yesterday. Okay, today he went on another ride averaging 12 miles an hour. In the 2 days, he biked a combined total of 12 hours. And this time it tells us what X wants to be equal to. So let X, so this one's nice to you. Let X be number of hours he biked yesterday. So hours yesterday. So obviously we need to write an expression for hours today. Well, again, I'm going to just pretend and make up numbers so I understand logically in my brain what is this like X stuff happening. So we know in total, yesterday and today, he biked 12 hours. So if he biked 2 hours yesterday, how many hours did he get today? That would have been 10. How did I get that? I did 12, the total, minus the hours yesterday, which in this problem right now is X. So that's how I arrive at 12 minus X, which is, by the way, completely different if you're going to say X minus 12. You're not going to get the same answer. It's the total minus the yesterday. Okay, so make sure you guys are not making that mistake. All right, and so what we're doing is writing an expression again, not an equation, writing an expression for the combined total of miles he biked in the last 2 days. Okay, so yesterday equates to the orange highlight of 9 miles an hour, so 9x. We're going to add that to the 12 miles an hour. So it's this 12. I know there's two 12s in the problem, but I'm talking about this 12. 12 miles an hour times the today expression, which is 12 minus x. Okay, it could be written like that if you're just submitting this to Alex. Know that if you like get a multiple choice question on a test and it's distributed and simplified like number 1 was, then go over that. But I'm not going to do all that work for you. I just want you guys to get to the point of knowing how to write an expression. So I'll stop here. If you need to simplify, go for it. But remember, there's no equal sign. So you can just distribute and add like terms and we'll be done. Okay, last one, number 3, kind of reviews geometry, which you guys just came from. So this should be a little bit of a fun review. It says the sum of the 4 angle measures of any convex quadrilateral is 360 degrees. Suppose that a convex quadrilateral has angle measures of 90, 3y minus 8, and 10y minus 10. So these are 3 of the 4 angles in a quadrilateral. It says write an expression for the degree measure of the 4th angle. It didn't say find the 4th angle, it says write an expression. So again, no equal signs. I can't reiterate that enough. All right, so let's start with just adding these 3 angles together, okay, to get an expression. So if I do 90 plus 3y minus 8 plus 10y minus 10, combine like terms together, I should get 13y plus 72. So that's all 3 angles added together. I want to find the 4th angle. Okay, so again, if you don't know what to do, think of an example. So if I have a quadrilateral, which adds up to 360 degrees, and again, let's just pretend 3 angles add up to 300. Then what would that 4th angle be? Okay, that 4th angle would be 60, right? So all we did again was subtract. So we're going to subtract what the 3 angles are equal to, which is here. So 13y plus 72. Big mistake if you just leave it like this. Okay, it's minus this entire expression. You need to put that expression into parentheses because it's 360 minus that whole little thing. Okay, because that way you do not forget to distribute this negative sign. Again, those sneaky negative signs are what's going to make you subtract small points off your test. So you're subtracting 72 instead of some people are going to falsely add 72. So your final answer would be negative 13y plus 288. That would be your, again, expression for the 4th angle. All right, so now we're going to, this was like having 2 unknowns. There's 2 things in each problem. Now we're going to go to 3 unknowns. I think you guys tend to like these ones a little bit better. They tend to be a little bit more easier for you to do. All right, so it says Jane, Blake, and Ryan have a total of $70 in their wallets. Blake has 10 less than Jane. Ryan has 2 times than Jane. How much does each have? Again, we're still only using one variable, so I don't want you to say like X, Y, and Z or something like that. We're still using one variable. So your first thing you should be doing in these problems is designating who is X. And I'll give you a hint. It's usually the person where everything's being done to. So I'll explain what I mean by that. So it says Blake has 10 less than Jane. Ryan has 2 times what Jane has. So I feel like everything's being done to Jane. So she should be X. So X is equal to Jane. Okay, now we're going to write Blake and Ryan based off Jane being X. So in that second sentence, it says Blake has 10 less than Jane. So 10 less than Jane would be X minus 10. And then Ryan is 2 times Jane. So 2X. Okay, I want to see this on your guys' papers. People who try to do this in their head and designate your expressions typically get the smallest errors wrong. So please just designate, take the time on the left-hand side just to designate your expressions and then move on with the problem. All right, so in total they have $70. So now you're just going to add all of them up. So X plus X minus 10 plus 2X equals 70. So 4X minus 10 equals 70. So X equals 20. And a couple people are going to stop there and say that's your answer. Please, as always, read the question, answer the question. X equals 20, but the question is how much does each have? So you just got to plug X into each of your three expressions. So we know Jane has $20. That leaves Blake with $10 and Ryan with 40. And since this is like a real world problem, you can totally check your answer to make sure that this makes sense according to what the problem asked. Because if you get like different answers, you're obviously knowing that this does not make sense in particularly to the problem. All right, number 2. Over the last 3 evenings, Layla received a total of 119 phone calls at the call center. The second evening, she received 5 more calls than the first evening. The third evening, she received 4 times as many calls as the first evening. How many phone calls did she receive each evening? Okay, so again, you want to pick strategically what X is going to be. I read the first evening several times, so I feel like X being the first evening would be really smart to do. And you're going to start to see once you do these problems, you're going to easily be able to tell the more you do which one should be X. Okay, and you could pick something different than that if you wanted to pick second evening. It's just that your expressions are going to be a little bit more complicated than mine, but you should arrive at the same answer. Okay, so now let's write the second evening expression and the third evening expression. So it says the second evening she received 5 more than the first evening. So 5 more than the first would be the second evening. The third evening, she received 4 times as the first. So 4 times the first, which would be the third evening. Okay, and then read it carefully because, for example, on tests, this is where we would trick you. For this sentence here, the third evening, she received 4 times as the first evening. What if I just changed that to second evening? This is where people mistakenly don't read carefully. If I said 4 times the second, it would be 4 times in the second. Right here is X plus 5. Okay, people always just want to say 4X because they just get into this general habit. So just make sure you're just reading carefully. But as we know in this one, we went a little easy on you. So it's 4 times the first, and the first is X, so 4X. And then in total, she received a total of 119 phone calls. So we're going to add all this up and set it equal to 119. Okay, combine like terms and solve for X. Again, do not stop at X equals. Make sure you guys are always answering the question. So the question is, how many phone calls did she receive each evening? So I'm going to have 3 answers. The first evening, she received 19 phone calls. The second evening is 24, which makes the third evening 76. Again, something you could easily check to making sure that this makes the word problem make sense. So pause here, try number 3 all by yourself, and then return back for the answer. All right, number 3, you should get 16 for Ahmad, 7 for Rita, and 48 for Chris. So again, you're done with section 1.3, so we should now have 1.1, 1.2, and 1.3 topics completely done at the end of today.